Hey, trig class, I'm going to go through the next little few questions that deal with what quadrant are we working in given the signs of these trig functions. So the signs meaning if they're positive or negative. So I've got my unit circle out. They're going to help a lot on these types of questions. So what I'm looking at here is a place where sine is positive but cosine is negative. So sine is positive anywhere the y coordinates on the unit circle are positive. Remember, the sine is the y coordinate, and the y coordinate is positive when we're above the x-axis. So all of this part of the unit circle is above the x-axis. So there's where sine is positive. It's any of those angles that I've got highlighted there on that top part of the unit circle. Now in contrast, this says cosine is negative. Cosine is the x-coordinates on the unit circle. And the x-coordinates are negative when we're to the left of the y-axis. So that means it's any part of this semicircle, the left-right semicircle. Those are the places where cosine is negative. And if you're looking, this is the region where both are negative. It is right here, which puts us in quadrant 2. All right, and that's what we're doing with these questions. We're taking the information that we have and we're saying, all right, which one satisfies both of these? And so in this case, it's quadrant 2. That would be our answer. All right, let's look at the next one. Let's see what information we have this time. Now we have sine is negative, and so is tangent. All right, so let's start off sine being negative. Sine are the y coordinates on the unit circle. So on the y-axis, it's negative when we're below the x-axis. So any of these points on the unit circle are going to have y coordinates that are negative. Now if you recall, what we said was tangent is the slope of the line segment that connects the origin to the points on the circle. So you can think of this as saying a negative slope for these line segments, like that line segment right there, or that line segment right there. Now that line segment I just drew is a positive slope, so that would not be a part of this region because tangent, the line segment, has to have a negative slope. So any of these slopes that we're seeing here are negative, and then also these are, because these are just like the continuations of the ones that stopped at the origin. So those have negative slopes. So that's quadrant 2, and this is quadrant 4. And you can see in quadrant 2, I don't have any yellow, so it has to be that we're in quadrant 4. So that's how I could do that with the tangent. All right, let's look at this next question and see if we can tell. Cosine is positive, tangent is positive as well. Right, cosine is positive, that's the x-coordinates, so positive x would be there. So that means we're on the right semicircle. All right, and then tangent being positive again means the slopes are positive. So this is a positive slope from the origin. That means that these are positive slopes as well. So it's quadrant 1 and quadrant 3 where the slopes are positive. All right, but quadrant 1 is the only one that has the green semicircle. So that means quadrant 1 is the region that we're in. All right, now let's look at this next type of question. Skip ahead a couple. So what we have to do on these problems, when we're told what one value of a trig function is, but then we're also told something about another trig function, just its sign, not its value, we have to use that, this information along with the output is like those previous problems. It's going to put us into a quadrant, and then we have to figure out the 6 trig functions. So it's very similar like we talked about before. If all I was told was this, that sine is equal to negative 1/5, that's a y coordinate. The y coordinate is negative 1/5. Well, again, down here is negative 1, so there's like negative 1/2. Negative 1/5 would be maybe like right there. So we could be, again, if you follow this all the way over, I could be here on the circle, or I could be all the way over here. So I could be in quadrant 3, or I could be in quadrant 4, but if tangent has to be positive, again, that's the slopes of these line segments. That's a positive slope. That's a negative slope. So it can't be quadrant 4. It has to be quadrant 3. And you can see that in quadrant 3, the value, like for instance, the value of cosine is negative. In quadrant 4 of the value, cosine would have been positive. So that's why that's important to know which quadrant we're in to begin with. All right, so in quadrant 3, cosine is negative, tangent's positive, and obviously sine is negative because we were given that to begin with. So sine's negative. Now, when we have the reciprocals, like the cosecant's reciprocal of sine, they keep the same sign. So cosecant will be negative, secant will be negative, cotangent will be positive, and that's going to be important once we get all our values, like we've seen with previous problems. All right, so I know I'm in quadrant 3, so I'm going to go to the left and down to draw this picture. It's basically like I'm going to the left and then down, like to hit some point on the circle. It's kind of like I'm drawing that triangle. I'm just not drawing it on the unit circle. All right, sine is opposite over hypotenuse. So I'm going to say this -1 is the opposite. Here's my angle theta, and then here's the hypotenuse, 5. Right, that means this is the right angle. And so I can do the Pythagorean theorem. So I get the square root of 24, rationalizing, that's going to be 2 times the square root of 6. Okay, 24 is 4 times 6. All right, and 4 is a perfect square. So I'm taking the square root of 4, getting 2, and just leaving the square root of 6. That's where that's coming from. So this side here is 2 times the square root of 6. All right, cosine is the adjacent, which is this side we just came up with, over the hypotenuse. So that's 2 square root of 6 over 5. And just remember, because we're in quadrant 3, that's going to be a negative. So the x-coordinate is negative. In quadrant 3, the y-coordinate is negative. So that's -2 square root of 6 over 5. All right, tangent is opposite over opposite over adjacent. So it's -1 over -2 square root of 6. But because of the two negatives, I can drop them. Negative divided by negative is a positive. So I have 1 divided by 2 square root of 6. All right, and now we're going to switch to the reciprocals. All right, cosecant is the reciprocal of sine. Sine is -1/5. So cosecant is just -5. All right, remember, they're going to keep the sign. They're just going to flip over. All right, secant is the reciprocal of cosine. So cosine had the 5 on the bottom, so it's going to go up to the top. The 2 square root of 6 is going to go to the bottom, but it's going to stay negative. All right, and then finally, cotangent is the reciprocal of tangent. So tangent was 1 over 2 square root of 6. Flip that over, you'd have a 1 on the bottom. So it's just the denominator, 2 times the square root of 6. Remember, when you have a 1 on the bottom, that's division by 1. You don't need to write it. All right, so there is how we can go through there and find these values of all 5 other trig functions if we're given one, and just the sign of another that puts us in the correct quadrant.